Okay, I think we can get started. I want to thank you all for being here. Looks like from the list of attendees, or maybe kind of all over the place. So good afternoon or good morning, wherever you're located. My name's Hugh Peterson. I'm the product manager for Standard Imaging, and I cover the DoseView line of water phantoms, among other things, including our PIPS Pro QA software as well, and our Beam Checker Plus for daily QA. But today I want to talk about the DoseView water phantoms. And this is not intended to be a deep dive, it's just kind of an overview of both the hardware we offer for our 1B and our 3B, but also kind of touches on the software as well. So I always get a slow response when I start my PowerPoint. There we go. So just a little bit of housekeeping. Today's webinar will be recorded for future review. Essentially, if you had registered for the webinar, you'll get an email with a link to the recorded webinar, so you can either review it again at your leisure, or if you have colleagues that you want to share it with, you can feel free to do that as well. You're all on mute, so if you have any questions, you'll see at the bottom of your dialog box there's a question section. You can put in your questions there, and I will touch on those at the end of the webinar. And also just a little bit about Standard Imaging. We were incorporated in 1989, so we've been around for just a little over 30 years, 30 going on 32 years now. We're based in Middleton, Wisconsin, which is just outside of Madison, Wisconsin. We've got a very good relationship with the University of Wisconsin, not only the Carbone Cancer Center, but also the University of Wisconsin Calibration Lab, the accredited calibration lab at the university, where we get all our ion chambers calibrated for your use. And in addition to, as I mentioned, the products that I cover, the Beam Checker Plus, the PIPS Pro software, and the water phantoms, we have a full host of QA products for radiation therapy, from our line of X-ray and ion chambers to our suite of electrometers, our 3 different electrometers for various needs, different phantoms, including our Lucy Phantom for stereotactic, which is kind of the gold standard for phantom dosimetry for stereotactic radiosurgery, and a number of different software packages, including our Linac View software, our Adaptivo for patient specific QA and log file analysis, as well as other software packages and hardware offerings as well. But today, like I said, I'm going to kind of discuss our DoseView water phantoms, and for some reason I'm not moving again. There we go. Sorry. The DoseView water phantoms that we offer our DoseView 3D, and we offer our DoseView 1D as well for depth measurements. I'll kind of be touching on both of those a little bit, and the hardware, and then kind of run through the software. And I'm not sure why my PowerPoint is not working with me today very well, but anyway, so the water phantom objectives, acceptance testing, of course, commissioning of your Linacs, annual QA, your monthly QA, the various TG142 tests, TG151 tests, TRS 398, et cetera. And then you also, of course, your periodic checks of beam quality as needed. And what makes a good water phantom? This is kind of goes without saying, but you want very good accuracy and very good repeatability. You want to be able to produce high quality raw measurements, so you don't have to do a lot of post-scan processing. You want reliable hardware and operation year after year, especially the 3D Phantom. Typically, it's not something you bring out very often. Best case scenario, you're using it once, maybe twice a year. But in that situation, you want to be able to bring it out, have it operational and reliable, and you want software that's easy enough where you don't have to like relearn it. You can get familiar with the software again very quickly. You want easy setup, and as I mentioned, you're only going to be using it best case scenario on an annual basis for those annuals. So you want to be able to set it up quickly and easily. And of course, you want that flexibility to for different compatibilities, not only for different types of detectors, be it ion chambers of various collecting volume sizes, but diodes, our X-ray and scintillation detectors for scanning as well for small field. You want various protocols to be able to be utilized, be it maybe the TG51, TG142, TRS398, various Japanese or Indian or Latin American protocols as well. So you want all those different protocols to be able to kind of be incorporated into the system. And along that line too, you want to be able to export into various tree and planting systems in various formats as well. And we have a number of different ones that are offered. As far as our hardware goes, we like to say, better hardware, better data, and that accurate and consistent positioning is something that's very important in working with a water phantom. We use a heavy gauge extruded aluminum frame, which maximizes your rigidity, it simplifies the setup, and it maintains that reproducibility. Everything is positionally accurate and repeatable within 0.1 millimeter axis, 0.1 millimeter per axis. It allows for a quick and easy 3-point leveling. And each individual system is tested on a in-house industrial coordinate measurement system. So even before the system goes out the door, we make sure that those accuracies and those repeatability points are maintained, not only with our 3D, but also with our 1D Phantom. A few points on our design for our 3D Phantom. Designed for ease of use. The frame and the tank are mechanically secured together, so that ensures a long-term integrity and rigidity for good quality scanning. We have something simple as our advanced suction drain. Basically, it's just a moat system around the base of the Phantom that helps draw water out of the Phantom as you drain it. So you don't have to have any residual water, and you don't have your armature and your scanning mechanism sitting in residual water. So it helps in keeping any oxidation or any mineralization off of your hardware. Then we have a fully integrated lift and reservoir cart with a precision positioning platform. We also have a optional lift cart, which is lift cart only with no reservoir, so that's available as well if that's desired. A couple more points about our positioning platform. There's a course rotational adjustments at 45 and 90, so you can lock it in at, it clicks in and locks in at 45 and 90 degree increments, so you have those diagonal capabilities, so you can lock it in to do 45 degree scans as well. And then we also, once you get a course adjustment under the collimator, we have fine adjustment levers for the X and the Y movement, as well as rotational in very small increments, so you can fine tune and get that precise adjustment to make sure that you're aligned under the collimator correctly. Also, about a year and a half ago or so, we introduced our new DoseView 3D Generation 2 hardware design. It's got a little bit of a lower profile. We've gone to those extruded aluminum frameworks, so it's a much better rigidity, but also it's a little more compact too. So it is Halcyon compatible. So if you do have a Halcyon system, it will fit in the bore, and you can do scanning with the Halcyon. We also have Halcyon specific lines on the sides of the tank for filling. Because obviously, a full tank, you would not, you'd be exceeding the couch limitation. So to make that easy for you, we have fill lines not only for a conventional couch, but also for Halcyon. I'm sorry, for our conventional Linac using our lift cart, I should say. But then also, if you have to place the Phantom on the couch in the situation with the Halcyon, it does not exceed the couch limits. We've got a wireless connectivity, very intuitive wireless pendant that has full motion capabilities on the pendant. It's got a digital readout, so you always know where you're at. You have the ability to do simple setup and system configuration from the pendant as needed. The onboard display, as I had mentioned, shows your probe position at all times. It's got a three touch button probe speeds, including a fast mode, a slow mode, and then our 0.1 millimeter step mode as well. Has a bias switch at the pendant, which is nice. If for some reason you need to go back into the room and you forget to turn the bias off and you need to do some adjustments, or you can turn that bias off at the pendant. So it just kind of saves you steps. We offer not only a wired conventional setup for the water phantom, but we also include a wireless radio system, so you can connect wirelessly to the PC as well. That's included with the system. Just kind of helps you kind of eliminate some of the cabling and some of the clutter that you might experience when you're using a water phantom. So it gives you that versatility and convenience. Long experience in electrometers. We've offered one of our first products out on the market were some of our electrometers, our Max 4000, our Super Max, our Premier 3000, our CDX 2000 electrometers as well. So we've got a long history and a long experience with producing quality electrometers. Our electrometer for our DoseView 3D is a charge digitizing electrometer, so you get that high-speed acquisition. It's got a 10 femtocoulomb resolution, so it's a very fine resolution. Have dual polarity bias, so you can set your biases accordingly. And then it also has independent bias voltages as well, so you can interchangeably turn one on or off if you wanted to use a diode for scanning, but you wanted to use an ion chamber for your reference. You can set those accordingly as well. And as far as the other time-saving features we've got a very innovative and versatile detector alignment system. There's a detector alignment jig here that you can see. Once you place that on the in the Phantom and get that to water level, you can visually and easily see where you're at with those water levels. Then this can be pulled off the carriage for the chamber, and then you'll see here we have various different holders for the chambers, from the scanning type chambers, farmer chambers, a universal holder, as well as various plain parallel plate ion chamber holders as well. And it's got kind of an innovative system where you have the ability to mount the chamber onto this jig here, which is included with the lined buildup cap for the correct positioning. Then when you take off the water surface alignment jig here, replace it with that chamber jig, as you see here. It puts that chamber collecting volume and the chamber in the exact correct position after you set it up. So it's very quick and easy to set up your chambers and get them aligned properly. We also have a automatic find beam center as part of the software package, which allows you to easily and quickly locate that beam center in the X and Y position to define the origin. And you can do that at multiple depths too, so you can check your runouts and make sure that your alignment is and your leveling is correct. Very quick and easy to do that. Then just jumping over quickly to the to 1D water phantom, we've got our 1D phantom that we've offered for quite some time. Two different size tanks, 3-point leveling system, so you can make sure that you're getting your accurate depth measurements as the chamber will track correctly in the downward or upward motion. And it's compatible as far as the software goes with both our Supermax electrometer and our Max 4000, including the Max 4000 Plus generation of electrometers as well. Our ion chambers with the 3D system, we include two of our X-Rated A28 0.125 cc volume chambers. Nice thing about these, they've got an actual spherical collecting volume. So if you're going cross-plane or in-plane, you don't have to do any adjustments for that. Being a spherical, you'll have good readout and good measurement from both directions, and helps you with that improved raw data and less post-scan processing after the fact. We also offer that complete line of X-rated detectors, our ion chambers, diodes, and our W1 and W2 scintillators. Everything from the smallest of the small 0.007 cc A16 chamber up to our large spherical chambers as well. All our chambers utilize a homogeneous Shanka plastic in a collector garden shell, so it's virtually invisible to the beam. It's low Z material. There's no perturbation of the beam because you don't have metal collectors in the field. The Shanka plastic is very robust, so they're much more robust and not as delicate as a graphite type thimble chamber. And with our conductive plastic, the Shanka plastic is conductive, so there's no flaking of conductive coatings, things like that over time. They're always going to kind of withstand any kind of radiation damage over time. They don't get brittle like a graphite chamber does. And then because of that, we have a proven X-rated quality, where we have a 5-year ion chamber warranty for our chambers. They're all inherently waterproof as far as our scanning chambers go. So no sleeves or no waterproofing kits are necessary for pretty much any of our cylindrical chambers at all. So that being said, I'm going to kind of jump into the software, which is going to take a little bit of the meat of our presentation here. But basically, it's it's an easy right to left, top to bottom navigation, like you're used to if you're using a Windows environment, which obviously probably most or all of you are. It's fully integrated now for not only our DoseView 3D but also our 1D scanning. We integrated that into our last version of the software, version 3.0, and we entered and gave a lot of the proven functionality of the 3D system into that 1D system. So you kind of use the same navigation, the same scan queue setup, things like that, and that things that were beneficial for our users for the 3D are now a component for the 1D as well. We like to say there's no hidden features in the software. Once you get into the software, everything's kind of at your fingertips. You don't have to go hunting and looking for different functionalities within the software. It's all right there for you. And we have very intuitive menus for not only scan queue setup, but also for measurement and analysis of the scans after taking your profiles or your depth measurements. So that being said, I'm going to kind of jump into the software here, give you a quick overview. Like I said, this is going to be kind of a quick overview. If you want to see the software more in depth, please feel free to contact us, and we'd be happy to set up a one-on-one demo with you so you can kind of see the actual software as it kind of steps through its paces. But that being said, I'm going to jump into the software here. So we've got our what we call our title page here. You can either enter into the DoseView 3D or the DoseView 1D. I'm going to jump into the 3D side here, and you'll see it's pretty simple setup here. We've got 3 tabs. We've got a setup tab, a measure tab, and an analyze tab. First order of business is to set up those clinics and machines. So here I set up a demo clinic and I set up a demo LINAC. My demo LINAC is set up for 6 MV. I've got my DMAX, my 9 MEV. I've got my DMAX there for those two energies. So as you easily set things up for different LINACs or different energies, it kind of walks you right through it. Same with detectors. I've got a bunch of detectors here set up already, but it's easy enough to add new detectors, the name, the manufacturer. We're kind of vendor neutral. If you have, obviously we'll realize that you would have other manufacturers' chambers most likely, so we can certainly set those up in here as well. You can put in your model, whether it's a cylindrical, a parallel plate, etc., the inner diameter, and that comes into play later when you do your dose conversions. So that's all in there, and then you have your little library of chambers here. For preferences, I'm gonna jump over scan queues real quick and jump into preferences. But this is basically where you set your date format. If you have you want written out day, month, things like that. Month, day, year, things. However, a bunch of different layouts for you there. Same with the time. If you have 24-hour clock or 12-hour clock, you can do that as well. as well as your decimal separators. You know, obviously in the States here, we use the period as a decimal separator. A lot of other regions use a comma, so you can set those as well as, and that includes your CSV delimiters too. What separates your CSV points, either a comma or semicolon, spaces or tabs, so you can set those up as well. So that's the preferences tab. Jumping into the scan queues, basically you've got a lot of different functionalities here, easy enough to add. We have copy and edit functions too. So if I set something up and I want to maybe copy that and edit it to, I set something up in 6 MB, but I want those same scans for 10 MB, I can just do a copy and edit for those. But setting up a scan queue, very easy, very straightforward. You'll see here we've got a few different components, the general, the energies, the field sizes, the scan types, and they're shown as not set. So as soon as I go ahead and do a set demo scans, you'll see that turns to complete and kind of guides you through where you need to be. You can set what medium, if you want to do scanning in water or air, what your modality is, if you want to do MV or MEV, or if you're doing triple F, your field definers, JAWs, MLCs. If you're doing SRS with cones, you switch over from a JAW or MLC architecture to a cylindrical diameter, basically for different cone diameters. Or of course, if you're doing electrons, you jump into the electron cones as well. And that goes for the modifiers. You can either use no modifiers, set up wedges, or if you're using electrons, you can put in for a cutout as well. So for this, I'll just kind of leave this as is. So I'm going to jump into energies now. I've got my energy set here. I've got 6, I've got 18. I can easily add a new energy if I want. I can delete energies if I don't have those on that specific machine. So I'm going to choose my 6 MV, choose my field size. Maybe for this scan set, I want to do 10 by 10, maybe 20 by 20. My scan, I can do here. I can also check my field size if I'm doing rectangular, or if I am using SRS cones, circular. I can set up my length and width. They don't have to be symmetrical. So if I want to do asymmetric field sizes, I can do that as well. So then jumping into my scan types, here's where you choose your in-plane, your cross-plane, your depth measurements. If I'm doing diagonals, I can set that up. I can do half scans in various directions as well, cross-plane and in-plane, positive and negative. So I've got that functionality. Also, the software will stitch those together, your half scans together to make a full scan, things like that. So that functionality is there as well. And so in this case, maybe I want to do a cross plane, I want to do an in plane, I want to do some depth measurements. You'll see a couple things popped up additional here. I can set my depths I want to maybe do one at Dmax. I want to do maybe 10 at 10 cm. My CAX offset, so if I want to do anything off axis, I can set that up here, but I want to do just central axis for this particular set. And then I can go into scan mode. And there's a couple different things for scan mode. You have the ability to choose either step or continuous. You have the ability to choose either single zone or multiple zone. So if you want to choose multiple zones, you kind of change the resolution. If you want a higher resolution in the shoulder and the penumbra region, you can do that accordingly. You can, like for here, I have it set up to do 2 millimeter scan measurements for the tail and the flat region, but if I wanted, and I can set it up doing 1 millimeter measurements in that penumbra area as well. So just kind of a little bit higher resolution there, and those can be reset or set to your liking. You can also choose your zones, how big you want your inner zone, how big you want your tails, your overscan distances as well. So those are all functionalities that you can do. Depths, so that's the profiles. If I want to move to depths, I've also got the ability to do step and continuous for the DoseView 3D. The DoseView 1D is step only. We have the ability to force that point at Dmax. So if I'm doing, say, an even set of measurements every 2 millimeters starting at, say, 30, and if I go and hit that 1.5 Dmax, if I do that scan, it will not hit that Dmax point because we're going even. So I can actually force that point at Dmax by just clicking on that, and it would go from then you have that 1.6 um, 1.6 cm, 1.5 cm, and then it will return back to that 1.4, 1.2, etc. So it'll return back to its original path. So just a nice little feature there for making sure that you do get a point measurement at Dmax. But that's all there is to setting up the queue. So you can see it's very quick and easy. Jumping into the measure page now, this is where you kind of set your hardware or your set up your queue. Nice thing we built into the software, since you might not be using it all that often. We have a demo function, so you can kind of do that offline, not connected to the tank. And it also works for me when I'm doing my demos like this, but gives you the ability to kind of get in, play around with it, kind of refamiliarize yourself with the software a little bit. So I make that connection to my demo 3D, I initialize it. You'll see that it goes ready as well. This is kind of set up similar to the scan queues, where anything grayed out needs attention. So my electrometer, I want to maybe set my bias for my field and my reference. I can zero my electrometer from here. I can also zero it from the pendant um, in the bunker as I set things up. So you got the ability to do your position. Here's your locate beam center that I had mentioned in the where you can, it'll run out in the X and Y direction, find that beam center and give you any kind of adjustment necessary. You can send the probe to any position here. You can set your origins here. You can go to the origin if you want as well. So those are the different functionalities within the hardware setup. But everything is blue now here, as you can see. So I can go to my queue. I'm going to load a queue here. I've got a test demo set that I did previously. So just tell me to check my dose rate settings, and that's in the hardware side. But I'm going to pretend that I already did that, so I don't have to go back to that. Nice thing too is it's color coded here. So I've got two different. I've got the blue set, and then the red, or I'm sorry, the white set or gray set. And basically that tells you that these are going to be my 20 by 20. I'm going to scan those, and then I need to make a change of some sort, either change energy, or I need to change my in this case I got to change my field size. So it just kind of breaks those down. I can go ahead and I can zero the electrometer from here. I can set up a normalization as well. I want to normalize this one for my Dmax. I can go to that position. I can normalize there. I can close it. And then I can begin my scans. Simple as that. You have your scans going here. I'm showing my depth here. Then I'll be going into my profiles. But it shows you here not only for the active scan showing in green, but also the percent that's done for that particular scan. So now that one finished and jump to the next one. So while that's continuing there, I'm just going to jump into my analyze page here and let those scans continue. A nice feature there is you can have active scans and still move on and go into a analysis of your scans. And once a scan is done, like you'll see here, these two bottom scans, while I'm still doing active scanning, I can start to analyze those existing scans. But for example, I want to maybe just analyze a few scans that I did previously. I can open those up. Those will populate on the scan page here, and you'll see not only I've got 3 scans for profiles, I also have 1 depth scan. If I wanted to show them all on one, I can do that as well. I've got various different filters. I can normalize to a specific profile. You'll see here, while I had my scans going, now that those 20 by 20 scans are done, it gives me my scan differences. Now I need to set my next field size from 20 by 20 down to 10 by 10, and I can go back to that. I set up my next field size of 10 by 10. I can start those scans going, jump back to the analyze. But for my profiles, I've got a lot of different filter sets here that you would utilize. A couple of smoothing filters. I've got a point edit filter. This is a Gaussian and a boxcar smoothing. I've got the ability to normalize to a specific value. I can normalize at the center. I can center the scan itself if I'm off a little bit. I can also do an average symmetric conversion here. I can flip and mirror my scans as well. And then I can also do a shift if I need to. And that is both for not only depth, but also the profiles. So you have that functionality. You've got your readout down here of your scan identifiers, but then you can go and click on the metrics tab. You've got your flatness and symmetry measurements, your minimum and maximum percentages, your central axis position, your penumbra widths, your edge, etc. So all the pertinent metrics are there as well. And then it'll show you any filters. It automatically will normalize to a specific value here. For this one I did, being that it was a pre-done set of scans. But if I wanted to, do a shift, that would show down here as well. You can always clear all your filters. You can clear your last specific filter as well. So you've got different functionalities there. You have different protocols here you can set up for either APM or your IEC, your Varian, your AARB, if you're doing triple F as well. So you can choose those accordingly for your different metrics calculations. So that's kind of some of the functionality there. We have various export capabilities of our scans. So you can choose a different export type. We've got the clip. We can export to Eclipse, to Monaco, Electa's Aqua QA platform, Pinnacle, Research. Our new version coming out in the near future will add CyberKnife to that as well. We can also export to CSV or PDD or TPR tables, so we can do those also. Our DoseView software. So if you wanted to do it or a DoseView format. If you want to export it, say, to a DoseView format, and you want to import it to another PC, if you're a consulting physicist and have our software on a laptop versus a clinic PC, you can export those to there as well. Another nice feature we have, if you have a legacy system, say an older PTW or IBA, you can also import some of your older legacy scans into the DoseView, so you can do an analyze and comparison there as well. So that functionality is there also to be able to import existing older scans. We have version 3.1 is coming out, and that will give you the ability to set a specific set of reference scans, and then that will give you the ability to kind of compare newer scans to that set of reference scans, not only in the metric side of things, but also we'll have a gamma analysis will be added to it as well. So that'll all be, we're just about finished with that, ready to go into final testing for that version of the software. So we're hoping to have that out by the end of the year or just after, but that's kind of where we're going as well. But that kind of gives you, just like I said, a quick overview. It's not a whole lot of in-depth stuff. If you do want a little bit more of an in-depth demo, feel free to let us know. We'll be happy to do that. I'm going to kind of jump back to the PowerPoint now and just kind of run through kind of some of the last summaries of the systems that we offer. So we've got our hardware, very structurally rigid software, hardware designed for excellent repeatability and accuracy, positional precisions and accuracies to within 0.1 millimeter per axis. It's got that quick system setup both for the 1D and the 3D. Wireless functionality on the 3D for ease of use and setup. They have the fast acquisition electrometer with the independent bias settings for both the 1D and the 3D, and it's got that intuitive, versatile detector alignment system, not only for the 3D, which I showed you, but then the 1D also comes with a universal detector system, and we have different detector holders as well for plane parallel ion chambers, things like that. So we've got kind of all the bases covered. Software-wise, it's a fast queue setup for not only depth scans, but also for your profiles on the 3D side for all energies and modalities. We do a conversion of our depth scans to dose for export of those to not only PDD tables, but also TPR tables. We do that export to a number of different treatment planning systems. We've got that selected force point at DMAX. Something I didn't show you on the 1D side was also easy single point measurements, fast queue setup for our software. Everything is left to right, top to bottom navigation. Everything is is at your fingertips. There's no hidden functions, as things like that. That's all right there for you as easily as well. You got step or continuous scanning and the multiple zone resolutions. We've got, like I said, the export to all these different treatment planning systems. Nice thing too is those are all included. You don't have to pay individually for different treatment planning systems. We have export to all of them automatically included with the system, both on the 1D and the 3D side. That import functionality for legacy scan data from other scanning systems, and a very straightforward post-scan processing and metrics as well. So, like I said, that's kind of just a quick overview. I'm very happy to have you contact your regional representative to set up something that might be a little more in depth. I'd be happy to do that. Again, coming soon in DoseView 3.1, as I'd mentioned, that enhanced scan comparisons, which includes both a scan gamma comparison, but also a reference scans that the user can set, and then subsequent scans can be compared back to that as well. So it's a nice setup feature there. And then that TPS and TPR table export to CyberKnife, and those are both coming soon in 3.1. But other than that, that's kind of all I have today. I thank you for joining me, and I'll take a look at the questions here if there are any in just a second. I just want to again say, this was just a quick overview. If you want to see it more in depth, feel free to either email me at hpeterson@standardimaging.com or sales@standardimaging.com, and your email will get directed to your correct regional rep or distributor, as the case may be. And we can set up a private individual demo for you and your colleagues as you desire. But please feel free to visit standardimaging.com as well and kind of see not only more information on the DoseView systems we have, but also the full line of standard imaging. And now I'm going to kind of jump into see if there's any questions. I don't see any questions that were brought up, but again, if you do have any after the fact, please let me know, and I can get those questions answered for you. Additionally, like I said, looking forward to hearing from any of you that might want a more in-depth demonstration. So thank you very much. If you are attending ASTRO, I hope you're having a good meeting, and hopefully in the near future, if you're not attending ASTRO, we'll have some time to get together face to face at one of the upcoming meetings. Thank you very much. I hope you all have a good day.